In this video, I'll discuss about data types and data structures in R and data structures in R. And R actually takes a wide variety of data. It can work with numerical, character, or logical data. It has different structures, like it can define a data in form of scalar, vector, matrix, data frames, factor. I'll be discussing about factor. And there are higher dimension arrays that R can define. R can work with higher dimension arrays and list. So we'll be discussing about these different data structures. In this video, I'll focus myself, I restrict myself to scalar, vector, and matrix. Okay. So before going into data structures, uh, R can read numerical and strings. Okay. Typically, R define strings as character. So we will have two categories, numeric and character. Okay. In numeric, we can have integer values or floating point values. So what I'll do, I'll move to our studio screen. Where is my R studio screen? This is my R studio screen. And I'll discuss how we define numerical value. So as I said, in form of structures, data structure, there are three. One is scalar, the other one is vector, third one is matrix. We have already discussed about these data structure in form of previous videos, but what we'll be doing it, we'll be having a detailed discussion about these. Scalar is typically it's a single value variable. Okay. So for example, I'll go to console. If I say A is equal to 5, so what it is doing, this 5 value, it is assigning or storing this 5 value in a vector A. Okay, I'll hit it. If you look at, once you run your R, what happens? Value of A will appear here. That's a scalar value. You can have a scalar in form of B as in form of character. So how you define character in R? With an inverted comma. This is how R understand character. I'll say Delhi. So B, the name of the place Delhi is stored in a variable B. So this is how B is a character. So both A and B are scalar value because they have a single value, whether either in form of scalar or numeric or in form of character. Okay. So this is the first variable, first data structure. Vector are typically one-dimensional data set. I'm saying one-dimensional because these are series of value either in form of in terms of, if you want to understand this in terms of data, either it will have row or it will have column. That's the meaning. So either in rows or columns. Okay. So these are vectors. Vector can have completely numerical vector. Vector can also have completely character vector, and it can have a combination of numeric and character. So we will actually work with these uh, kind of data structures. So let me have a first vector. We've already worked with this. We using the function C, which is binding values together. So let me have a first vector, which is completely a numeric vector C. It has values 43, 20, 45, 20, 24, 34. Okay. So if I run this, how it looks like, you can look at your environment, X1, which is a number. It has 4 values, and these are the 4 values. Suppose X1 is a character. Okay. So how you can say it contains name of the places, comma, Mumbai, comma, Chennai, comma, Kolkata. Okay. So if you actually storing the name of places in a variable x, now this variable x is a character variable. Okay, we can look at x1, CHR is character. It has 4 variables: Delhi, Mumbai, Chennai, and Kolkata. So this is either this x1 is either in form of row you can define, or in form of uh, column. Okay, so vector is one dimension. This is one dimension. Hmm? Vector can also have a combination of number and uh, character. So let me have x1, which is 3 comma 5 comma Delhi comma rest. Maybe I'm using a random word. So if I run this, how does it look like? X1, what it has done it, because R is, we have identified this as character. So we have loaded these two values as character. What now R cannot say the entire vector is numeric vector. So R is confused because there are certain elements which are characters actually. So what R has done, R has identified numeric values as character. You can look at. Okay. This is how we identify vector. Suppose you by chance you write like this instead of the way I have written. You can write like 3 comma 5 comma Delhi comma rest. What will happen? What will happen? I'm running it. Okay, because you have written without inverted comma. You have written Delhi and rest without inverted comma. My R is slow. What is actually happening? I'll run it again. It's saying Delhi is not found because R is not able to identify the term Delhi. Okay, because either I would have given a numerical value, assign a numerical value to this Delhi, or I would have identified this as a character. I have not done this. Nothing I have done here. Neither given any assignment to a numerical value, neither assign any numerical value, nor I have given defined this as a character. So yeah, the R system is confused, and this is kind of category. You can say this is a syntax error because I have not defined it, and it's telling me that Delhi is not a defined object. Okay, so this is what we have to be careful when we define a vector. So what I've discussed about, these are the three important how we define a vector. Now, as I said, vector is a one-dimensional variable which has number of values into it. How do I identify which value is what? There is a square bracket. I think I've already discussed last time. This is very important. There are two important symbols. One is parenthesis. Okay, I'll write in the notebook. So parenthesis. So this defines function. I'm reiterating, and square bracket. Okay, this defines elements of your data. I'm using the term data. I'll just say. So in this case, currently what we have a vector. Okay, and suppose my vector is x1, which has 4 elements. So I'll say x1, identify the third element. What is the third element? So I have to put a square bracket and this third. It means what is the third element of x1? I'll just hit a enter button. So the third element of x1 is value, like in this case, 1, 2, 3. This is how R reads data. The first value it will identify it as the first element, second value as second, third, fourth. This is different than Python. In Python, the first element is defined as zero index. Now in this case, this R, first element is first index, second element is second, third, fourth. In case of Python, it would have been 0, 1, 2, 3. Okay, so this is the kind of difference that you have to keep in mind. So this is how R reads individual data. Okay. So you suppose you say, what is the first value of x1? What is the first value of x1? 3. Now 3 is actually, it is reading as correct. In many cases, when we load data, because sometimes data has either from the external resources or we have inputted data, in many cases this data has a combination of numeric and character, like what I'm doing right now. So how do I convert my numeric character value into numeric? So this x1 is character. I can directly convert this x1 into numeric. So I'll say y1 is equal to, the command function is as dot numeric. This function will convert the vector which is defined as character in form of numeric. Okay, let us do this and we'll look at. Okay, this is how it's doing it. I'll run. Now what is happening? There is a warning it is showing actually. I'll discuss about this warning, but let us look at the y1 values. Y1 value is appearing over here. So what it is doing, it is defining y1 also has 4 values. What it has done, because 3 can be, in a way you can remove inverted comma. So in, in this part, R has removed inverted comma. 3 is a numeric value, that's okay. 5 is a numeric value. R cannot understand the numerical assignment to Delhi and the rest. So these are definitely, these are actually the character values. So what it is doing, it cannot understand Delhi and this. So what it has done, it has assigned NA values to it. And this is why it's showing warning. NA is introduced by coercion. Okay. So when you convert a vector which has numeric and character, combination of numeric and character, and you use as dot numeric function to convert them, what will happen? It will force the values which are character, it will force them to NA. So that is what you have to keep in mind. Okay, this is very important when you work with the large data. This understanding will be very useful. Okay, so this is all about vectors, the element of vectors. Now I'll move to the next important data structure in R, which is matrix. We have already worked with matrix. Last time I have defined a matrix. So let us do this right now. Let me define a variable x, c, some 8 values or 9 values, 23, 45, 67, 23 again, 40, 46, 1, 2, 3, 4, 5, 78, 89, 7, 34 and 56. Okay, so this is a value of a. Okay, now let us do little twist. Instead of 34, I can change this as Delhi. Okay, and let's turn it. X is right now character with 9 values. I want to create a matrix Y. Okay, so the function is matrix, which we already discussed a number of times. What I give input of x and row equal to 3 and call equal to 3. So if I create this, what is going to happen? Y is your character matrix, which has 3 rows, 3 columns. So let us look at how Y looks like. I'm double clicking it, and this is Y looks like 23, 45, 67, 37, 23, 46, 70. But remember, each and every number, it's not really a numerical value. Everything is right now in form of character. If I actually course Y and say convert values of Y in form numeric, I'm storing a value this in a new matrix. So what will happen? Let's see. So Y2. Y2 is actually as dot numeric of Y. Same warning is appearing here. NAs are introduced by coercion. But what is actually happening, instead of taking this as matrix, it has taken this as vector. Let us look at Y2. So when you apply this as dot numeric function, your matrix will be converted into vector. This is what you have to keep in mind. So this is the vector. Now you can create matrix again. Y3 is equal to matrix Y2 comma n row equal to 3 comma n col equal to 3. So if you run this, what will happen? Y3 will be a matrix, and now this Y3 has numerical values, and wherever I put Delhi, it's reading as NA. So this is how your matrix is defined. You can convert your matrix into a vector into matrix. Now what, as I said, square bracket is a specific arrangement which is used to define your data indices. So in case of matrix, you look at arrangement, you will have rows and columns. This is the kind of standard format of arrangements, okay? In matrix, how matrices are defined, metrics are always defined in form of rows first and column second, actually. Okay. Now suppose I say what is which element, what's the value of fifth row, sorry, second row and third column actually. Okay. So for Y3, what is the value of second row and third column? How would I identify? I'll define second comma third. Okay. If I look at this, the value is NA. Let me go back to Y3 again. What is the second row? Second row, third column is this one, NA. Okay. What is the value of Y3 for the second row and second column? Second row and second column, the value should be 46. Okay. This is the value. So this is how you define your matrix element actually. Now, interestingly, what we can do is Uh, this is very, I think, for a large matrix, because right now I'm showing a very small matrix, but if you have a very large matrix, you can also filter your matrix by this arrangement. So I say, if I say matrix, this is a variable, and if I say comma, I'll not write anything in between, and define my column number, maybe column. So what it will do, it will take all rows. If you're keeping blank, it means keep all, okay? And take specific column. For example, I say Y3 is my matrix. I'm keeping comma and saying take second column, okay? So what it is doing, it is keeping all rows for the columns 2. Let us look at 23, 46, 78. Let me look at the value of Y3. What is what are the three rows of second column? 23, 46, 78. 23, 46, 78. Okay. The other way is also useful. Matrix. You define row, comma. If you're keeping blank, it means all column. Okay. We will be using this. So now Y3. I'm defining row, which is second row, all columns. Okay. Now let us look at, let me actually first look at the Y3. Answers should be 45, 46 NA. Okay, let's look at 45, 46 NA. This is the second row and all. Suppose you only want to keep 2 rows. You don't want to keep other, okay, 2 rows. How would you do that? The command would involve matrix. Can you specify R1 to R2 if they are in continuous order? Keeping blank means all. Okay, so let us do this. Y3 1 to 2, R1 to R2, 1 to 2. I'm keeping only 2 and keeping blank, so it will create a new matrix which has only 2 rows and all columns. Same I can do with matrix all rows, column 1 to column 2. Okay, this is what I can do. Let me actually work with this Y3 matrix. all rows and column 1 to 2. Let us look at column 1 to 2 all rows. Okay. Suppose I want to keep only this part. I want to filter out this part. I don't want this and this. Okay. So how would I do this? Matrix 1 to 2 comma 1 to 2. Sorry. Okay. So this is the command. So y3 is my matrix 1 to 2 comma 1 to 2. Let us look at what is the value. 23, 23, 45, 46. It has removed. So in this way, this is an arrangement. This can be used to filter out large matrices. So in case suppose I simply wants to keep first and third row, because now 1 and 2 are in continuous order. But suppose I want to keep first and third row and fifth column, suppose. Okay. So matrix, my first and third row I want to keep, and I want to keep fifth column. Sorry, not there is no fifth column, third column. Okay. First and third row and third column. So let us look at how it works. I have to define first and third row. So 1 and 3, I can concatenate in a single vector. So to concatenate, what we can use the C command. Then it's a function. So I'm using parenthesis 1 comma 3. So I've concatenated. So this is how the formula works actually. So in case of y3, I'm concatenating uh, 1 comma 3. This is the first vector defining first and third row and third column. Okay, this is how it looks like. First and third row and third column, because only one value. So let us look at first and third row 23, and third row, I'm sorry, let us look at C1 comma 3 comma 3. So the third column is this, and first and third row are this 89 and 56. Okay, suppose you want to keep all columns, you will simply keep it blank, and this is first and third row. First row is 23, 23, 89. Third row is 67, 78, 56. So this way you can filter out matrix in any form, and this is a very interesting and useful filtering methods actually. Typically, you can work with this with the large data set also. So this is all about mainly two important data structures, vector and matrix in R. In the next video, we'll discuss about other important data structure in R.